Hey everyone, welcome back. This is going to be the last review video for Math 2 through your journey through mathematics in my class. It's a little depressing, honestly, but that's okay. That just means we're growing and we're getting ready for the next adventure in our lives. So in this review, you guys were supposed to answer all these questions, and you notice that all these questions were dealing with graphing and domain and range included with that. We focused on the idea of graphing lines and graphing parabolas. So let's go ahead and take a look at the first problem here. It says graph the following function and then match the graph to the option given. You can see all the multiple choice options. I'm not going to bring those up on any of these, but we're just going to graph it on this coordinate plane here. So what we notice here is that this function is a line. It's linear. Well, how do I know that? It's linear because the x has a power of 1. The highest exponent of the variable is 1. So I know it's a line. And this is slope-intercept form. So we know that the y-intercept is 0, 3 because of this plus 3. Remember, y equals mx plus b, where m is the slope and b is the y-intercept. So that means we're going to start by going up 3. And then from there, we're going to follow the slope pattern. Well, in a line, the slope pattern is a constant slope. In other words, the slope doesn't change. So the slope is 1/2. Well, what does that mean? That means we have a rise of 1 and a run of 2. Now, that's normally how teachers will express it. It's up 1 and right 2. And in a line, there's nothing wrong with that. But we know that when we're talking about quadratics, if I see a coefficient here that's a fraction, it doesn't mean go up 1 and over 2. It means you go up 1/2 and over 1. In this case, it puts you in the same place because you're going to follow that pattern all the way through. But what I should really be doing is going up 1/2 and over 1. And then up 1/2 and over 1. And I end up in the same place that I would before. Now I want to be consistent with this slope as I go along, so I'm going to go up 1 and over 2 again, up 1 over 2 again. And keep in mind that I can also go the other way. I can go down 1 and back 2, down 1 and back 2, and so on. Now, the reason I can do that is because if I'm going down, that is the negative direction, and if I'm going back, that is the negative direction. So a negative divided by a negative is a positive, and that works out because the slope is a positive value. We can double check our work because we can see that this line from left to right is increasing. These values are going up. It's increasing. Anyways, let's go on to number 2. Number 2 is very much the same thing. We have a line with a y-intercept of 2 and a slope of -5/3. So again, technically you should be going down 5/3 and over 1, but because this is a line, we can follow through that whole pattern and just go down 5 and right 3. Now, what some students want to do in this, okay, I'm going to take a step back here. What some students want to do is that they see this -5/3 here, and so they want to go down 5 and they want to go back 3. No, 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 no. Because this is a negative slope, that implies two things. That implies that only one of these values is negative. The other one has to be positive. Because if I go down 5 and back 3, then what I'm doing is I'm going negative over a negative. So a negative over a negative would actually be a positive value. And that's not what I have here. I have a negative slope. So it's down 5 and right 3. Remember, the other thing is, since the slope is negative, we should see from left to right, we should see our line going downhill. We should see it decreasing. So if you see that if you're going from left to right, you're going uphill and you have a negative slope, something went wrong there. So be careful with that. You're going to go down 5 and right 3, a negative over a positive. Well, you could also go up 5. That would be a positive direction. But that means we'd have to go back 3, -3, because a positive divided by a negative is a negative, and a negative divided by a positive is also a negative. So we want to kind of be consistent that we're checking that sign. So there's my line there. All right, for number 3, This is the same type of thing. It's linear, but what I like about this problem is that there's not a fraction in front. What does this 2 mean? Well, first of all, we have a y-intercept of 1, so we're going to go up 1. And then the slope here is 2. Well, what does that mean? We want to write this as a fraction so we can see the ratio between the change in y over the change in x, or the ratio between the rise and the run. So what I need is to go up 2 and write 1, because this is 2 over 1. Up 2 over 1. Up 2 over 1, and so on. But again, I can go backwards. I could go down 2, but that means I would have to go back 1, because a negative over a negative is a positive. So down 2, back 1, down 2, back 1, and so on. And then we connect the dots and we get our line here. For number 4, now it's a little bit of a different twist. We're talking about the domain and the range. We're given the graph, and we're asked for the domain and the range. Now remember, the domain is the set of x values in a function. So x values are our horizontal values. So how far to the left do I go in order to start this line? Well, you can see that the line starts here on the left-hand side, and it ends here on the right-hand side. So what I like to do is to draw vertical lines that kind of put boundaries on the function. So from left to right, well, at the left-hand side, where did I start? I started at x equals 0. Now somebody might say, well, y equals 4. You're right, y does equal 4. But because we're talking about the domain here, we're talking about the x values. So we start at 0 and we end at 5. So we know that our domain is from 0 to 5. So we would say 0 is something in comparison to x is something in comparison to 5. In other words, the x values for this graph are going to be in between 0 and 5. The next step is to figure out what kind of inequalities we're going to put here. We know that this is always going to say less than. It's never going to say greater than. That doesn't make sense. We don't say 0 is greater than x, which is greater than 5, because that would imply that 0 is greater than 5, and that's not true. It's 0 is less than x is less than 5. But we have to determine whether we have equal signs or not. Well, we notice on the 0 that it's an open circle, which means that the line or the function doesn't actually touch 0, it just gets really close to it. So we put a less than sign there. We don't put an equal sign at all because it doesn't actually equal 0. Whereas on the other side, the 5, the function has a closed circle there, which means that the function actually does hit the value of x equal 5. So we'll put less than or equal to. So that's our domain. For the range is the set of y values, so it's the up and down. So again, I'm putting lines as boundaries for the function that I'm talking about. So remember, range is the set of y values, and the way we answer this is we say, okay, there's the y. What is the part that is below the graph, and what is the part that's above the graph? In other words, how far down do I go? I know that there's some confusion on these types of questions because we think, oh, this was the lowest value, x equals 0, so it must also be the lowest y value. No, it's not. It's not the lowest y value, it is the lowest x value. What is the lowest y value? The lowest y value is this dotted line down here. That is a y value of -1. So it goes from -1, and then the highest y value is 4. So we have an inequality that's going to say -1 is less than y is less than 4, and we just have to determine whether we have equal signs or not. So looking at the -1, does this line actually hit y equal -1? Well, again, this was closed, which means the function actually does hit -1, so it's going to be less than or equal to -1 is less than or equal to y. And then for the 4, this was an open circle, so the graph doesn't actually hit the y value of 4, so we don't put the equal sign in our inequality. So that's number 4. Let's go ahead and take a look at number 5 now. Same question, what's the domain and range? So remember, domain is the set of x values. So what is the x interval? We know we're going to draw these bounds, left and right bounds, so vertical lines, starting at, in this case, starting at 1 and going to 4. So we know that those are our bounds. And then as far as inequalities go, this is open. so we're just going to put less than. We're not going to put less than or equal to, just less than. And this is closed, so we're going to put less than or equal to. So that's the domain. And then for the range, it's the set of y values, so we're going to draw horizontal lines that represent the lowest and the highest. Well, the lowest value here is -4, right? -4, and the highest value is -1. Now we're looking at our inequalities. At the -4, we have an open circle, which means the graph doesn't actually touch -4, so it's just less than. And for the -1, we can see that it's a closed circle, so it's going to be less than or equal to. All right, for number 6, same concept. What's the domain and range? So again, domain is the x values, range is the y values. So we're going to draw these vertical lines, and we can see that these vertical lines bound this function starting at -5 and ending at 4. So we have from -5 to 4. Because this is an open circle, it's just going to be less than, and because this is a closed circle, it's going to be less than or equal to. So that's our domain. For range, it's a set of y values. So the lowest y value is actually way up here, right? It's a very small range, essentially. So we're starting at 4 and we're going to 5. So 4 is less than y is less than or equal to 5, because again, it doesn't actually touch 4, so we don't put the equal sign, but it does touch 5, so we do put the equal sign down in our inequality. All right, looking at number 7. Number 7, now we're transitioning back into parabolas. How do I know it's a parabola? Because when I expand all this out, my highest exponent is going to be x squared, right? When I FOIL or distribute this, however you want to look at this, the highest exponent will be x squared, so I know it's a parabola. Well, in this case, this form is written in vertex form. Vertex form is, remember, y equals a times x minus h squared plus k. And so we can see our vertex in this. Because this is a positive 2, we know that the vertex has an x value of -2. Remember, we changed the signs on what we see here. And then this says plus k, so since that says plus 2, our vertex is going to be -2, 2. Remember, when we're identifying our vertex from vertex form, we change this sign and we keep that sign. So -2, 2. So we can plot that point of -2, 2. That's going to be right there. The next thing we have to look at is our slope. Well, because this is a parabola, the slope is not constant. The slope changes as things go on. So the way we determine that is we look at our slope pattern. Remember, the normal slope pattern is 1, 3, 5. But because our a value here is -1/2, we have to take our 1, 3, 5 and multiply it by, well, I put 1/2 here. It should really be -1/2. But when I do that, I get 0.5, 1.5, and 2.5. It should be -0.5, -1.5, and -2.5. The only thing the negative does is it tells me that the parabola is opening downwards instead of upward. So from our vertex, this initial slope pattern means I'm going to go down 1/2 and over 1. So I'm going to go down 1/2 and over 1. So notice I'm not on a specific crosshair there. From here, I'm going to go down 1.5 over 1. So from here, I'm going to go down 1.5. Well, this is a half, and then another 1 puts me here, and I'm going to go over 1. So there is my next point. And then the next one, I'm going to go down 2.5 over 1. And I can keep going with this. I could go down 3.5 over 1. So as we go along, we can see that the slope is actually getting steeper, or the function is actually getting steeper. The slope is decreasing here. On the other side, it's the mirror image. So we're going to go down 1/2, back 1, down 1.5, back 1, down 2.5, back 1, and so on. And then we'll do our best to graph our parabola. And so this is me being very careful in graphing it. It is as close to perfect as I can make it, at least. All right, so that's my parabola. Let's go ahead and go on to number 8. Number 8 is another vertex form. Well, here we have a -4 and a +1. So remember, we change the sign here and we keep it here. So our vertex is going to be +4, 1. And our slope pattern, so I'll plot the vertex there, our slope pattern is normally 1, 3, 5, but I'm going to multiply that by the a value of 2. So our new slope pattern is 2, 6, and 10. So from our vertex, we're going to go up 2 over 1, up 6 over 1, and up 10 over 1. This is actually, this graph is a little bit off here, so I'm going to move it. It just seems like it's a little bit off. I'll do my best to move it where it's supposed to be. There we go, that's a little bit better. On the other side, we're going to go up 2 back 1 and up 6 back 1, and we're out of room, so we can't go up 10 back 1 at all. All right, from there, we're going to do our best to graph our parabola, and we end up with a nice parabola that opens up because the a value was positive. Now, something I wanted to note here, I didn't really get into this, and if we had normal time in the class, we would have talked about lines. So going back to linear functions and expressing them in different ways. You know how a parabola can be written as standard form, or it can be written in vertex form. This is vertex form. The other form, standard form, we'll get to an example of that in a minute here, but the standard form looks a lot like slope-intercept form of a line. We can actually make this a line by cutting out this squared. And this is something that you're probably going to talk about next year in your Math 3 class, that if I get rid of this squared, all of a sudden this becomes a line with a point of 4, 1. So instead of a vertex, we just have a random point of 4, 1. That's my starting point. And then from there, this would be my slope. It's not a matter of the slope changing. The slope would be a constant 2. So I'd go up 2 over 1, up 2 over 1, up 2 over 1. If that squared wasn't there, this would be a line that has the same point as the vertex, but then we would just be consistent in our slope of 2. That's a side note. That's something that you'll probably talk about next year. Let's go ahead and go on to the next problem. All right, let's see. All right, for this problem, number 9, you notice that the parabola, or the quadratic, is written in standard form, so we can't identify the vertex straight off by just looking. We have to find the vertex some way. We could use completing the square to find the vertex. I find it a little bit easier to just plug it into that formula to find the axis of symmetry first. So remember, that's x equals negative b over 2a for your axis of symmetry. So that would be x equals negative 4 over 2 times 1, which is 4 over 2, or 2. So that's my axis of symmetry. My vertex, to find my vertex now, I'm going to take that 2 and plug it into my x values to figure out the y value. So that would say y equals 2 squared minus 4 times 2 plus 8. Remember, we do exponents first, so that'd be 4. Then we do multiplication, and then we combine everything, so we end up with 4 there. All said and done. So my vertex is 2, 4. So I plot that point, 2, 4. And then from here, I look at my slope pattern. The a value in standard form is the same as the a value in vertex form. Since the a value here is 1, that means I'm going to go up 1 over 1, and then up 3 over 1, and so on. It's just the normal slope pattern, 1, 3, 5. Same thing on the other side, and then I'll graph my parabola from those points the best way I can. So that's number 9. For number 10, we are asking for the domain and the range. So again, we're going to put this kind of in a box. Remember, the domain is the set of x values, or the x interval that this parabola exists on. Notice that it starts at x equals negative 2 and it ends at x equals 2. So we would say negative 2 and 2. Because this is an open circle, we're going to use less than for this one. And because this is a closed circle, we're going to be using less than or equal to for the second one. For the range, it's a set of y values. So we're going to draw a horizontal line at the lowest point, and we're going to draw a horizontal line at the highest point. We see that the lowest point is when y equals negative 5, and the highest point is when y equals negative 1. Now normally parabolas go on forever, and so do lines, but notice we restricted the graph here, and so that's what causes our domain and our range to be something other than negative infinity to infinity, or at least our domain. What is the lowest point? Well, we don't want to mirror or mimic exactly what's said in the domain. We have to look at the range here. We have to look at the y values. So negative 5 is down here. Does the parabola actually touch negative 5? It does. The vertex here was 0, negative 5. So we're going to put a less than or equal sign there. And then for the negative 1, the question is, does the parabola actually touch negative 1? And the answer is yes. It doesn't touch it on this side, but it does touch it over here, so it's going to be less than or equal to in both cases there. For number 11, again, domain and range. So the domain, we're going to draw vertical lines to cut off our parabola, or to bound our parabola. We notice that our parabola starts at -4 and it goes to 4. Not all parabolas will have the same x values here. Probably should have come up with different examples here so we could see something a little bit different. But over here we can see that it doesn't actually touch x equal -4, and it doesn't actually touch +4 over here, so those are just less than and less than. For range, we're going to draw horizontal lines, one at the lowest part of the parabola and one at the highest part. And so we could see that the lowest part is -4 and the highest part is -2. And down at the lowest part, does it actually touch the -4? Well, it doesn't touch -4 here, and it doesn't touch -4 here, so we're just going to put the less than symbol there. And does this parabola actually touch -2? Well, yes, because that's part of the vertex, so it's going to be less than or equal to there. Okay, in our last problem, number 12, again, domain and range. So we're going to draw vertical lines, cutting off our x values. We can see that it starts at -4 and ends at 4. It does not include those, so it's just less than and less than because there's open circles. And then for our range, we're going to draw horizontal lines. The lowest horizontal line is 1, and the highest horizontal line is 5. Does the parabola actually touch y equals -1? Yes, it does, because that's the vertex, so we'll say less than or equal to. Does the parabola actually touch y equals 5? No, because those are open circles, so that's just less than. And so that is the range for number 12. All right, that wraps up this review. I hope that you got something out of this. Remember, we are going to have our last test on Thursday, so make sure that you are ready for that. You want to do well on it because that's going to be kind of our last assignment for the year. With that said, I will talk to you later.